The Sun is already killing Earth, and it started about 4.6 billion years ago. Right now, at this exact second, our star is 10% brighter than it was when dinosaurs roamed this planet, and it will never, ever dim back down. That's not a metaphor. That's orbital mechanics, and it has a countdown clock attached to it. Fact number 1. The Sun has been getting brighter your entire life, and every human life before yours. Here's what makes this genuinely unsettling. The Sun increases in luminosity by approximately 1% every 110 million years. That sounds slow until you do the math. When life first appeared on Earth roughly 3.8 billion years ago, the Sun was putting out only about 70% of its current energy output. Scientists actually call this the faint young sun paradox, because that level of solar energy should have kept early Earth frozen solid, yet somehow liquid oceans existed. Fast forward to today, and the Sun is 10% brighter than it was when complex multicellular life emerged 600 million years ago. And it will be 10% brighter again in another 1.1 billion years. That single incremental percentage point, compounded across geological time, is quietly tightening a noose around every living thing on this planet. The process has already begun. You are living inside a slow-motion extinction machine powered by the very star that made life possible. Visual note, animated luminosity graph showing sun brightness percentage plotted against geological epochs, color-coded timeline from Earth's formation to projected future. Use warm orange to white gradient to show increasing intensity. Fact number 2, in approximately 1.1 billion years, Earth's oceans will literally boil away, and nothing can stop it. This is the first hard deadline on Earth's death certificate, and it has been calculated with remarkable precision. In roughly 1.1 billion years, solar luminosity will have increased enough that Earth's average surface temperature will rise beyond the threshold for a runaway greenhouse effect. At that point, the oceans don't gradually evaporate, they destabilize catastrophically. Water vapor floods the upper atmosphere, and because water vapor is itself a powerful greenhouse gas, it amplifies the warming feedback loop until the process becomes irreversible. The technical term is the moist greenhouse threshold, and once it's crossed, there is no planetary mechanism to pull it back. The oceans, all 1.335 billion cubic kilometers of them, containing 97% of Earth's water, transition from liquid to atmospheric vapor on a geological timescale, leaving behind a scorched, dry rock orbiting a slightly brighter version of the Sun we see today. Researchers at the University of East Anglia modeled this process in 2013, publishing their findings in the journal Astrobiology. Their conclusion: complex multicellular life, the kind that includes every animal and plant you've ever seen, has at most 1.75 billion years remaining. The ocean evaporation event at 1.1 billion years eliminates the habitat for most of it far earlier. Visual note, split panel infographic, left side shows current Earth ocean volume as a to-scale blue sphere against Earth's diameter, right side shows the same Earth at the moist greenhouse threshold with a heat index color chart showing surface temperature escalation. No graphic imagery, strictly diagrammatic. Fact number 3, a single solar flare almost wiped out modern civilization in 2012, and we missed it by 9 days. Before we get to the deep future, let's talk about what the Sun almost did to us 12 years ago. On July 23, 2012, the Sun released one of the most powerful coronal mass ejections ever recorded in the space age, a Carrington-class solar storm that would have, according to a NASA-funded study published by physicist Daniel Baker at the University of Colorado, caused between $1 trillion and $2 trillion in damage to Earth's electrical infrastructure in the first year alone. The recovery time was estimated at 4 to 10 years. The reason you've never heard about this? It missed Earth by 9 days. The ejection traveled in a different orbital direction. 9 days earlier in Earth's orbit around the Sun, and every satellite, power grid, internet backbone, and GPS system on the daylight-facing side of the planet would have been simultaneously fried. The 1989 Quebec geomagnetic storm, which was significantly weaker, knocked out power for 6 million people for 9 hours and damaged transformers as far away as New Jersey. The 2012 event was estimated to be 2 to 4 times more intense. NASA's own assessment, published in the journal Space Weather in 2014, described the probability of a Carrington-level event hitting Earth within the next decade as approximately 12%. That probability resets every decade. We are, statistically speaking, overdue. Visual note: animated orbital diagram showing Earth's position on July 23, 2012 versus the trajectory of the CME. Use a simple clock face-style orbital ring with the 9-day gap highlighted in red on the ring. Pair with a color-coded severity chart comparing the 1989 Quebec storm versus the 2012 near-miss. Fact number 4. The Sun will expand to 256 times its current size, and that number was only pinned down in the last 2 decades. When the Sun exhausts the hydrogen fuel in its core in approximately 5 billion years, it will begin fusing helium and expand into what astronomers call a red giant star. The scale of this transformation is almost impossible to visualize. The Sun's current radius is approximately 696,000 kilometers. As a red giant, peer-reviewed stellar evolution models, most notably the 2008 study by Klaus-Peter Schroeder and Robert Conan-Smith published in the monthly notices of the Royal Astronomical Society, calculate that the Sun will reach a maximum radius of approximately 256 times its current size. At that diameter, the Sun's surface will extend to roughly 1.2 astronomical units from its center. Earth's current orbital distance is 1.0 astronomical units. Do that math and you arrive at a genuinely staggering conclusion: Earth's orbital path will exist inside the body of the Sun. Now, there is an asterisk, and it makes things stranger, not simpler, which is why it earns its own dedicated fact coming up. But the sheer physical expansion alone is a number that astronomers only nailed down with this level of precision after advances in stellar modeling in the early 2000s. For most of human history, we knew the Sun would become a red giant. We didn't know exactly how big. Now we do. And the answer is terrifying. Visual note: scale diagram showing current Sun radius versus red giant radius with Earth's orbital distance marked as a dotted line. Use a logarithmic scale visualization so both sizes are visible simultaneously. Color code: current Sun in yellow, red giant expansion in deep amber red gradient. Fact number 5. Earth might actually escape the red giant, but the escape route involves something even worse. Here's the plot twist that most science communicators skip over, and it's the detail that makes solar scientists genuinely uncomfortable. As the Sun expands into a red giant, it will simultaneously lose mass, shedding it as solar wind at a dramatically accelerated rate. According to the Schroeder and Smith 2008 model, the Sun will lose approximately 28% of its total mass during the red giant phase. This matters enormously because of orbital mechanics. As the Sun loses mass, its gravitational grip on the planets weakens, and Earth's orbit expands outward. Theoretically, if the mass loss happens fast enough, Earth's orbit could migrate outward beyond the expanding solar surface and the planet could physically survive the red giant phase. The problem is the timing. The Schroeder-Smith calculations show that Earth's orbital expansion will lag just barely behind the rate of solar expansion during the critical final phases. Their conclusion: Earth gets engulfed, but only barely, only in the final stages, and only because the tidal drag from the Sun's outer atmosphere at close range will suck Earth's orbit back inward faster than the mass loss migration can compensate. So Earth threads the needle of survival only to be pulled back at the last moment by the Sun's own dying atmosphere. It's the cosmological equivalent of almost escaping a black hole. And if you think engulfment is the worst-case ending, hold on, because what happens before the red giant even fully forms is arguably more catastrophic for life. Visual note: animated orbital migration diagram, show Earth's orbit as a dotted circle expanding outward while the Sun's red giant radius expands as a solid sphere. Use a time-step slider graphic showing the race between the two expansions, with the final convergence highlighted. Fact number 6. The Sun will boil Earth's surface to 2000 degrees Celsius, while still technically a star, not a red giant. Most people assume Earth's story ends with red giant engulfment. But the actual sequence of destruction begins hundreds of millions of years before that, during a phase called the subgiant branch, and the temperatures involved sound like they belong in a metallurgy textbook, not a planetary science paper. As the Sun gradually exhausts its core hydrogen over the next 5 billion years, it will swell moderately, not to red giant proportions yet, but enough. approximately 1 billion years before full red giant expansion, the Sun's increased luminosity will have raised Earth's surface temperature to conditions where the surface rocks themselves begin to glow. Thermal models show surface temperatures on the sunlit side exceeding 1000 degrees Celsius during the late main sequence phase, climbing toward 2000 degrees Celsius as the subgiant expansion accelerates. For context, the melting point of granite, the rock that makes up the bulk of Earth's continental crust, is approximately 1215 to 1260 degrees Celsius. The planet doesn't wait to be engulfed to be destroyed. It melts first, slowly, over millions of years, like a crayon left on a dashboard in slow motion measured in geological epochs. The oceans are long gone by this point, remember, they boil away at the 1.1 billion year mark. What the subgiant Sun destroys is the rock itself. Visual note: temperature timeline infographic. Horizontal axis shows time in billions of years from present, vertical axis shows Earth surface temperature in Celsius. Plot key thresholds: current average temp, ocean boiling threshold, granite melting point, and estimated peak pre-engulfment surface temperature. Use a heat map color gradient from blue through orange to white hot. Fact number 7. After the Sun dies, its corpse will remain radioactively hot for longer than the current age of the universe. When the red giant phase ends, the Sun won't go out like a candle. It will shed its outer layers in a glowing shell called a planetary nebula, a process that takes roughly 10,000 to 20,000 years, and leave behind a white dwarf. A white dwarf is the compressed carbon-oxygen core of the former Sun, roughly the size of Earth but containing approximately 54% of the Sun's original mass. The surface temperature of a newly formed white dwarf is approximately 100,000 Kelvin, roughly 17 times hotter than the Sun's current surface. Now here is the fact that genuinely stops astrophysicists in their tracks: a white dwarf cools almost entirely through radiation, and it cools extraordinarily slowly. Theoretical models of white dwarf cooling, formalized by researchers including those at the Universitat Politècnica de Catalunya, project that the Sun's white dwarf remnant will take longer than 10 trillion years to cool to a theoretical black dwarf, a cold, dark stellar cinder. The current age of the universe is 13.8 billion years. 10 trillion years is approximately 725 times the current age of the universe. No black dwarf is believed to currently exist anywhere in the observable universe because the universe simply hasn't been around long enough for even the oldest white dwarfs to finish cooling. The Sun's corpse will outlast virtually everything else in the cosmos except the longest-lived red dwarf stars. Visual note: logarithmic timeline graphic show the age of the universe, the projected lifespan of the Sun's white dwarf cooling period, and the lifespan of longest-lived red dwarf stars, all on a single comparative bar chart with color-coded sections. Make the white dwarf cooling bar visually dominant to convey the timescale. Fact number 8. There is a precise window between now and 600 million years from now, when Earth could theoretically be saved, and scientists have actually calculated the engineering requirements. This is the fact that takes everything we've covered and turns it into something genuinely extraordinary. Because scientists haven't just mapped the destruction timeline, some of them have published, in peer-reviewed journals, the theoretical requirements to save Earth from the Sun. The concept is called planetary migration engineering, and its most cited formulation comes from a 2001 paper by Don Korikansky, Gregory Laughlin, and Fred Adams published in Astrophysics and Space Science. Their proposal: use repeated gravitational flybys of a large redirected asteroid or Kuiper belt object, something in the range of 100 kilometers in diameter, to transfer momentum to Earth across millions of repeated orbital passes, gradually nudging Earth's orbit outward by approximately 50% over the next 6 billion years. The math works. The orbital mechanics are sound. The engineering requirements are, by any current human standard, incomprehensibly beyond us, but they don't violate any known laws of physics. The critical window for beginning this process is calculated to be within the next 600 million years, before the moist greenhouse threshold makes the outcome irreversible regardless of orbital position. The universe is 13.8 billion years old. Technological civilizations capable of planetary engineering could theoretically exist. And the most haunting implication of this research is not that Earth will be destroyed, it's that the timeline for prevention is already, in astronomical terms, frighteningly short. every million years of inaction narrows the window. The countdown is not hypothetical. It is a published number, in a peer-reviewed journal, sitting in a database right now. Visual note: orbital migration diagram showing Earth's current orbit versus the target migration orbit at 1.5 AU. Use a clean, color-coded concentric ring diagram. Overlay a countdown-style infographic showing the 600 million year intervention window against the 1.1 billion year ocean boiling threshold. Keep all visuals diagrammatic and academic. And that's the full picture. The sun gave life to every organism that has ever existed on this planet. It also carries the precise, calculated, peer-reviewed schedule for ending all of it. From the 1.1 billion year ocean evaporation event, to the 2000-degree surface baking on the subgiant branch, to the red giant engulfment in 7.5 billion years, to the white dwarf remnant that will still be glowing 10 trillion years from now, none of this is speculation. It is science. It is documented. And it is, somehow, the most awe-inspiring thing about the star we take for granted every single morning. Subscribe to Moonlit Minds for daily mind-blowing facts that will change how you see the world.